we take an example. We take an example. Find the vector equation to the tangent line. Find the vector equation to the tangent line, to the trace to z is equal to 10 minus 4x squared minus y squared at the point 1, 2. At the point 1, 2. Now here, what do we need? We need f of 1, 2. Now, f of 1, 2, okay, what is z? We need z, f of 1, 2. We need the z component here, right? F of 1, 2. When I put 1 and 2 in this equation, I get okay, fine, let's do it. When I put 1 here, I get 4. When I put 2 here, I get 4. So it's going to be 2. Right? So 2. So it means my A, B, f of A, B is equal to 1, 2, 2. Next, we need fx and fy. Fx is minus 8x and fy is minus 2y. I need fx at AB, which is 1, 2, and fy2 at AB, 1, 2. This here is giving me minus 8 and this minus 4. So I can write my vector equation now, right? So the first one, which is r of t, equal to a, b, f of a, b plus t 1, 0 fx at AB. Now remember, this is the equation of the tangent line caused by the trace with fixed y, right? Fixed y. Now A is 1, B is 2, this is 2, plus T 1, 0. Now that is minus 8. Okay. So this here is going to give me vectors when we are adding, right? Okay, let me just write it here. 1, 2, 2, plus 1 is 1 plus 1, I get t 0 minus 8 t. Coming up here, I have r of t is equal to 1 plus t 2 and 2 minus 8 t. Now this is the vector equation of the tangent line to the trace caused by fixed y. Likewise, that to the trace caused by fixed x. If you follow the slides, it is trivial, it is very simple. and that one is going to be 1, 2 plus t, 2 minus 2t. Please work out together, right? This is equal to the slope to the trace of the tangent line, right? The equation of the tangent line to the trace caused by fixed x is this, right? So follow the slides and see whether you can get that. Okay. Okay. Let's look at higher order derivatives. Higher order derivatives. Now, we can take higher order derivatives. Okay. Now, we know of if a function depends on 2 variables, right? Then we can find del f, del x, and del f, del y. This may be a function of x and y. You understand? So we can differentiate this, we can take a second derivative by differentiating this again, right? I want to differentiate that with respect to x, and this is going to be this. And this is going to give me del square f over del x squared. That's how we put it, right? I can also differentiate del f, del x, del y with respect to x again. And it's going to give me del squared f, sorry, that, over del x, del y. Okay. We can have third, this is second order, we have third order, fourth order, fifth order, and stuff. Okay. Let me take you through this notation. Likewise, if somebody say f, if you write fxx is equal to del squared f over del x squared. If we write fx y is equal to del squared f over del y del x. If we say del fx x yz, right? This is equal to del cube f del z del y del x. Now, what I want you to note is that when assuming you are given this to do, right? You do del f del x first, then del f del y, then del f del z. That is the notation, okay? But when you come to this notation, we differentiate f with respect to x first, then y, then z. I hope you got that. Let's take an example and move on. We want to, if f of x, y is equal to cos 2x minus x squared e to the power 5y plus 3y squared, right? Let me check my time whether I'm in range. Okay, I am. Alright. We can find fx, which is equal to del f del x, right? If I differentiate cos with respect to x, I'm going to get minus sine 2x. Differentiate here with respect to x, I'm going to get 2. So go to minus 2 right? Okay. If I differentiate this still with respect to x, I'll get 2x e to the power 5y. There is no x here, so here goes to 0. Next, I can find fy, which is del f del y. And if I differentiate this one here with respect to y, there is no y here, so everything here goes to 0. This one here is going to give me minus 5x squared e 5y plus 6y. I can find fxx, what is just differentiating del f so fxx means I'll now differentiate this one here with respect to x again, and that is going to give me minus 4 cos 2x minus x e 5y. I'm going through this very fast because I assume by now you are familiar with differentiation. Okay, and fyy is I differentiate del f del y with respect to y, and that is going to give me minus 25 s squared plus 6 plus 6. I can again differentiate, I can find fxy, and that is differentiating del f del y with respect to x. This with respect to x. And I'll just get minus 10 e 5y. There is no x here, so it goes to 0. Okay.